This meeting is being recorded.
In problem 30 from chapter 14, we are given 10 compounds here, and we're asked to calculate the degree of unsaturation for each of these molecules. So what I've done is I've given us two helpful hints here, two bits of information, one an equation and the other a reminder of the generalized formula of a saturated compound. So if for example, one of our compounds, if we plug in the N value for the number of carbons into the N for the number of hydrogens, and we generate this C to the N and then H to the 2N plus 2 formula, then we know that we have a saturated hydrocarbon, and therefore our degree of unsaturation will be 0. But if it doesn't follow suit, then for every 2 hydrogens that we have to remove, we know that that's 1 degree of unsaturation. And that's for just our hydrocarbon compounds. Our more complicated compounds that have halogens, we can use this formula shown over here on the right. So let's take a look at A, and our rationale here is if we plugged in a 6 for carbons, we would have to have 14 hydrogens. So we know that 14 minus 10, we have 4, and for every degree of unsaturation, we know 2 hydrogens are removed. So we have 4 divided by 2, and our degree of unsaturation will be 2 for compound A. Let's take a look at B. We can do something similar. We have oxygen now, but if you recall, oxygen will not affect the number of hydrogens in our compound. Therefore, it is just ignored when we do our determination. So for compound B, we would do 2 times 5 for hydrogens plus 2. Right, so we should have 12. So this has 1 degree of unsaturation. So what I did was 12. We see that there's 10 hydrogens, 2 are left, and we have that 1 degree of unsaturation. So 2, 1 so far. Now in compound C, we can plug in to this equation over here. So we would have 2 times the carbons, so 2 times 5 plus 2. And then we have plus the number of nitrogen, so plus 1, and then minus 9 for the number of hydrogens, and then we have no halogen. So this is our whole formula. So what do we have? 2 times 5 is 10, plus 2 is 12, plus 1 is 13, minus 9 gives us 4. So our final equation would be 4 divided by 2. So we would end up with an HDI of 2. So that's for letter C. Let's take a look at D. So again, we have an oxygen. We can ignore that, but we have a halogen. So we can use, again, our formula on the right. So we have 1/2, and then we plug in for 3 carbons, plus 2, plus, nope, not plus. Now we have a halogen. So instead, we're going to subtract. So we'll just do minus here. 1, so that gives us 6 plus 2. Oh, I just forgot to subtract my hydrogens as well. So let's do minus 1, minus 5. We'll extend this. So we have 6 plus 2 is 8. Minus 6 gives me 2. 2 divided by 2. I have my deficiency index of 1. All right, let's take a look at E. So again, we don't need to use the formula with the halogens and the nitrogens and everything when we only have carbon and hydrogen. What we can do is plug in N of 10. So we should have 2 times 10 is 20 plus 2. So we do not have 22 hydrogens, so I'll subtract what we have. So we have 2 left. We divide by 2 hydrogens removed for every level of deficiency. So then for compound E, we have an HDI of 1. All right, let's look at these last 5. We'll move a little quicker. So now we have a halogen. So let's plug in 1/2 times 2, or 1/2 times 2 times 4, and then we have plus 2. I'm going to subtract my hydrogens and then subtract 2 halogens. So I have 8 plus 2 is 10, minus 6. We get 4 minus 2, so I'm left with 2 over 2 for compound F. So this has a HDI of 1 here. G, we can use this formula over here. So I have 6 for carbons, and then I would need 14. What I see is that 14 minus 6 gives me 8, divided by 2 hydrogens removed for every degree of unsaturation. This has a HDI of 4, or a degree of unsaturation of 4 for compound G. Next, we have 2 carbons and only 2 chlorines. So what we would do here is, if we were to plug this into our equation, we would say, oh, I'm sorry, and 6 chlorines rather, not only 2. So we would plug this into our formula, and let's do that down here. 1/2 2 times 2 plus 2, and then minus halogens. We have no hydrogens. So 6 minus 6, we have a 0 degree of unsaturation, or an hydrogen deficiency index equal to 0 for this compound. Then we know we ignore oxygens in compound I. We have 2n plus 2 would give us, for C2, we would have 6 hydrogens needed, so 6 minus 4 gives us 2, divided by 2 for every degree of unsaturation. So for I, we have our HDI of 1. And then for our last compound shown here, we have 100 carbons. So let's plug everything in. Let's change color here so we don't overlap. So we're going to have 100 times 2 times 100, and then minus 200, and oh, we forgot the plus 2 here, minus 200, and then minus 2 for our halogens, and we ignore those oxygens. So we have 202 minus 202 collectively. So for this last compound, we end up with a degree of unsaturation of 0.